Let's look at another example, maybe using L'Hopital's rule, maybe not, I guess we'll see. Here I have limit as x approaches 1 from the right-hand side, 1 over x minus 1 over natural log of x. I say, let's try plugging in 1. Let's just see what happens. 1 over 1 minus 1 minus 1 over natural log of 1. This is 1 over 0 minus 1 over 0. And oh boy, we're in some trouble here. You may want to look at the limit of each one of these two terms separately. Here I will speed up the process a little bit. If you look at 1 over x minus 1 as x approaches 1 from the right, here that right-hand limit matters a great deal. If I look at 1 over x minus 1 from the right-hand side, I'm going to have 1 over a very small positive number, which means that this should approach positive infinity, minus, and then I'll do the same thing with natural log of x. Again, as x approaches 1 from the right-hand side, natural log of x approaches 0 from the positive side. So I have 1 over 0. This should approach positive infinity here. I end up with infinity minus infinity. This is yet another indeterminate form. Indeterminate. Okay. So I have this indeterminate form, but L'Hopital's rule will not work with infinity minus infinity. We said L'Hopital's rule will only work if our limit ends up with 0 over 0 or infinity over infinity. So we need to come up with another way to rewrite this expression. This one I think is a little bit more straightforward than the last example that we looked at. Here I see two fractions. I say, let's just try and find a common denominator. That's kind of where my mind goes. So I'm going to start by looking at limit as x approaches 1 from the right-hand side. This is 1 over x minus 1 over natural log of x. I'm going to get a common denominator here. So the left-hand term I'll multiply by natural log of x over natural log of x. The right-hand term by x minus 1 over x minus 1. So let's see, I will have limit as x approaches 1 from the right, natural log of x, my denominator here, x minus 1, natural log x, minus x minus 1 divided by x minus 1 times natural log x. I'm just going to distribute this minus sign here so that we don't forget to do that. Otherwise, it's a really easy mistake to make. So when I write this as a single fraction, I've got limit as x approaches 1 from the right-hand side. I have natural log of x minus x plus 1 divided by x minus 1 times natural log of x. So okay, we're getting somewhere. Let's try plugging 1 in now, and let's just see what happens. Natural log of x, here, let's do this. Natural log of 1 minus 1 plus 1 divided by 1 minus 1 times natural log of 1. Natural log of 1 is just 0. Minus 1 plus 1, that's going to be plus 0. In my denominator, 1 minus 1, that is 0. And natural log of 1, we said that's 0. Here I end up with, well, 0 over 0. So, okay, that's no good. But that means we can use L'Hopital's rule now. I've ended up with 0 over 0, which means I can use L'Hopital's rule. So I would like to take the derivative of my numerator and the derivative of my denominator of this function that I've just highlighted here. So let's do that. Limit as x approaches 1 from the right-hand side, I'll have 1 over x minus 1 divided by x minus, here be careful, I almost made this mistake. When we take the derivative of our denominator here, I have x minus 1 times natural log of x. I do have to use my product rule here. So the derivative of x minus 1, that's just simply going to be 1 times natural log of x plus x minus 1, derivative of natural log of x, that's 1 over x. I'm going to clean this up just a little bit here. Limit as x approaches 1 from the right-hand side. We'll leave this as 1 over x for right now. Natural log of x plus, here I'll have x minus 1 over x. And we're approaching what value? Oops, 1 from the right-hand side. So let's try plugging in 1. Let's see if we get a different answer this time. So I should have 1 over 1 minus 1, natural log of 1 plus 1 minus 1, 1 minus 1 all over 0 plus 0. Oh boy, 0 over 0. So this is no good. We end up with 0 over 0 once again. So let's try L'Hopital's rule again. Just to make our lives a little bit easier, I'm going to rewrite these 1 over x's so that I don't have to use a quotient rule. I'm going to rewrite those as x to the minus 1 because I think that should be a little bit easier. So, okay, we're going to apply L'Hopital's rule one more time. We're going to take the derivative of this function this time. So I have limit as x, oops, and actually here, let me just make a note to myself. Here we're doing L'Hopital's rule. So limit as x approaches 1 from the right-hand side. For my numerator, I'll have negative 1x raised to the negative 2 power. Derivative of negative 1, that's just 0. Natural log of x, I have 1 over x plus 1 minus, this will be negative 1 times x raised to the negative 2 power. Looks like we might be getting somewhere here. I'm going to rewrite this. Limit as x approaches 1 from the right-hand side. This is really negative 1 over x squared divided by 1 over x plus 1 plus 1 over x squared. Let's try taking 1. Let's see what we get this time. Let's plug it in. Negative 1 over 1 squared. Hopefully we get an answer because I'm out of room here. Divided by 1 over 1 plus 1 over 1 squared. This is really negative 1 over 1 plus 1 plus 1. Hey, look at that. Negative 1/3. There is my limit. So again, here, when we look at this limit and we determine, okay, we have infinity minus infinity, which we know is an indeterminate form, we do need to rewrite that expression. You always need to be rewriting these so that you're looking at a limit that ends up as 0 over 0 or infinity over infinity before we can use L'Hopital's rule.